Right, we've talked about ionic bonding, so our little Lego bricks, our little atoms are going to be sticking together now, and we mentioned about ionic bonding. When one atom donates an electron to another atom, you get ion formation. One's a plus, one's a minus, and opposites attract, so they stick together. The second way this can happen is called covalent bonding. Now, have a look at this periodic table. If you remember, ionic bonding is between a metal and a non-metal, so one on the left of that zigzag and one on the right. Covalent bonding is between non-metals, two or more non-metal atoms joining together, so that's anything to the right of that red zigzag line. So, for example, methane. Methane is CH4. It's got carbon and it's got hydrogen. Now, I know on this diagram hydrogen looks like it's to the left of the zigzag line, but it's out there for a reason. It is a non-metal, okay? Everything to the right and hydrogen, that's the rule, is a non-metal. So carbon's not a metal, hydrogen's not a metal, so that must be a covalent bond. Can you think of anything else? Can you think of any other molecules that are formed from non-metal atoms? What's the most simple one? What's the most simple molecule that you first learnt about? Well, I'm guessing it's H2O. Hydrogen's not a metal, oxygen's not a metal, so you know that must be covalently bonded. So you might get a question where it simply asks you whether a molecule is covalent or ionic. So be sure that you know some examples of covalent and ionic bonding, and be sure you know where that little red zigzag line is so you can tell which one it is. Now, let's talk a little bit about the properties. These are simple covalent substances here. So we've got oxygen, we've got water, H2O in the middle there, and we've got CO2 down there on the right hand side there. All of those covalently bonded, all non-metal atoms. Now the forces between the molecules, what we call the intermolecular forces, are very, very weak. So just looking on the top left, look at the oxygen molecules. We've got 4 molecules of oxygen floating around. And the bonds attracting those molecules together are very, very weak, and that's why oxygen is a gas at room temperature, because these intermolecular forces are very, very weak. So the forces between the molecules explains why a lot of covalent substances are a gas at room temperature. If those bonds were stronger, they'd be stuck together and they'd form a liquid, or if they were even stronger, they'd form a solid. You do get covalently bonded solids, something as strong as diamond or graphite. They're covalently bonded. They're giant covalent structures. But these simple ones with the weak intermolecular forces are usually gases at room temperature. Have a look at this. We've got water. When water boils, when it comes out of your kettle as steam, they're still water molecules. They haven't changed. No chemical reaction has happened. So what that tells you is the intramolecular bonds, so the ones between the actual atoms, between the 3 atoms themselves, are really, really strong. So if you could shrink yourself down to molecular size, you could easily pull apart the molecules, but you'd struggle to pull apart the actual atoms. You need quite a strong force to do that. And that kind of explains why water can exist as a solid, a liquid and a gas. So let's have a look at this diagram here. We've got a positive nucleus pulling on the negative electron, and the electron doesn't come crashing into the nucleus like a falling stone, because it's moving around and around and around. So how would hydrogen go around? Hydrogen doesn't go around as single atoms, it goes around as H2. And let's have a look. This is what it looks like. We've got the positively charged nucleus of one hydrogen atom pulling on the electron of a different one, and the positively charged nucleus of the different one pulling on the electron of the first one. That's not easy to explain, but you can see on the diagram how it works. Each negative pulls in the other one's positive, and they stick together and they form H2. So hydrogen goes around as H2, as a diatomic molecule. Are they happy? Well, they've only got one shell. How many electrons go in the first shell? 2. So are they happy? Yes. They're sharing electrons, and this is the whole point of covalent bonding. They share electrons. One of them says, here, you can use this one if you like, and the other one says, you can use this one if you like, and therefore they're both happy because they've both got 2 electrons. And that is the whole basis of covalent bonding. No one's giving any electrons or taking any, and there's no ion formation. They're merely sharing electrons. And now, both of these positive nuclei are pulling on both of those electrons. So you can see why that's a really strong bond. We can draw covalently bonded molecules using where you can make them using the little Molly-Mod kits. But these are good because they show that they're not just 2D. When we always look at them on paper or on a PowerPoint presentation, they always look like they're two-dimensional. They're not. These things have 3D shape. You can also look at them using stick diagrams, ball and stick models, space filling models, and so on and so forth. Or you could just write CH4, which is the molecular formula. So there's a lot of different ways of looking at these things. Right, let's have a look at one then. Let's have a look at fluorine. Now, fluorine, what is the formula for fluorine? How are we going to work this out? Well, let's do what we usually do. Let's ask ourselves the question, how many electrons are there in the outer shell? And that should help us out. We're not going to bother drawing the thing. We don't even need to look at the 9 and the 19 and say 2 in the first, how many in the second. All we do, if you remember, if you watched the ionic bonding video, we look at what group it's in. There's fluorine, it's in group 7, and therefore it has 7 electrons in its outer shell. Right. How many electrons does fluorine want? It's got 7, it wants 8, so it wants 1 more. So what's fluorine going to do? Can you guess before the slide changes? Can you guess what's going to happen next? One fluorine comes along and says, I've only got 7 electrons. How about I share 1 with you, you share 1 with me, we stick together, and then we'll both have 2. And that's exactly what happens. This diagram here, the electrons of the one on the left are in red and the one with the blue on the right are in blue, and that's just so you can tell the difference between them. So the 2 positive nuclei are pulling those 2 electrons together, pulling them in, and that keeps that fluorine with a really, really strong intramolecular bond. And fluorine floats around like oxygen, like O2, as a gas in the air because the intermolecular bonds are very, very weak. So, by sharing electrons, they get a full outer shell. If that's the only thing you get from this PowerPoint, then make it that, right? If there's only one thing you get from it, make it that, because that's the important point. By sharing electrons, they get full outer shell and they stick together very, very strongly. So, that's fluorine. Let's have a look at another one. Let's ask a question. How many hydrogen atoms would nitrogen bond with? Hydrogen only wants 1 electron, remember? Now, how many electrons does nitrogen want? What group is it in? 5. It's in group 5, so how many electrons does it want? It wants 3 more to make it up to 8. Okay? So, hydrogen only wants 1, nitrogen wants 3, so how many will it bond with? Obvious, 3. Okay, so nitrogen will come along and say, okay, you 3 hydrogen atoms, I'll share with you, I'll share with you, and I'll share with you. You 3 share with me, and then we're all happy. Let's have a look at that. There we are. There's a diagram of it. The blue electrons are nitrogen electrons, the red ones are hydrogen, and they're sharing. Each hydrogen's got 2 in its outer shell, they're all happy, and the nitrogen's got 8 in its outer shell, so it's happy. Very strong intramolecular bonds between 3 hydrogen atoms and 1 nitrogen atom, and that forms a molecule called ammonia. So there you go, there's a slightly more complex one. How many hydrogen atoms will bond with an oxygen atom? You should maybe pause the video now and have a think about that. Okay, if you pause the video, then you should see that oxygen is in group 6. So oxygen needs how many more? It needs 2 more to make it up to 8. Hydrogen only wants 1, so once again, the middle molecule in this diagram you can see is going to bond with 2. And that's why it's H2O. Okay? That's why it's H2O, 2 hydrogens and 1 oxygen. And there's hydrogen there as well. So there you go, there's some more covalently bonded molecules. What are the chemical formulas for these compounds? So the one on the left, ammonia, 1 nitrogen and 3 hydrogens. So what would the formula be? NH3. The next one, the water one in the middle, not difficult. two hydrogens and one oxygen, H2O, and hydrogen there, we've got two hydrogens, so that's just going to be H2. Now, it can get a little bit more confusing, and don't worry about this, just recognise that this can happen. Oxygen can form what's called a double covalent bond. Notice each atom is sharing 2 electrons now. They have to do that because it's O2, and that's the only way you can form O2. That's the only way both atoms can be happy. And if you count up the red and the blue electrons in that last shell, you'll see that both of those atoms are happy. That's a double covalent bond, so that's even stronger. Really, really strong intramolecular bonds. Okay, so that's a look at covalent bonding. The only one we haven't done so far, we've done ionic bonding, we've done covalent bonding now, and there's one called metallic bonding, and we'll have a look at that in more detail later on. Thanks for listening.